Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VGSOM IIT Kharagpur who is taking this course for you. And in the last video, we were discussing about customer churn prediction. I have given a very brief feedback about why customer churn is important. In this particular video, we will talk about how to predict churning behavior. So, why don't we open this week 9 s2.r file. This file is where the data is there and the corresponding data that we will be using is a telco customer churn data. This has been downloaded from IBM's website, IBM Watson website. It is a freely available data set, is required to do academic work only. So, please use this data for that purpose, and we are opening this particular data. The data set looks like this. It's a big data. Let me explain first. There are, I think, how many? Around 7,000 observations. So, 7,000 customers are there, and if I further make it bigger, you can see in the left side the customer ID, then the gender, and then the whether this customer is a senior citizen or not, whether he has a partner or not, how many dependents, whether he has dependents or not, some demographic details about the customer is given. It has also been given that how much is his tenure, means how old is this customer in terms of months, that whether the customer is very old or not. Then if I come this side, I have also whether the customer has phone service or not, whether there are multiple lines, how many phone service is there, whether there are multiple lines or not. The internet service, what kind of internet service this customer has, whether it has a DSL or it has a fiber optic or it has no connection, those kind of things are there. Online security, if there is no internet service, then there is no requirement of online security. So, there is yes, no and no internet service. Similarly, online backup, if it is no internet connection, there is no online backup is needed. No device protection is needed, no tech support is needed. So, these are yes no questions, and streaming TV, streaming movies, whether they also consume those kind of things or not. So, telco is basically a telecom company, and they are trying to, telecom is a service company and they make money every month slowly. So, they are saying that whether which kind of services these particular customers consume and for how many months they are consuming the services with me. This tenure is actually how many months they are consuming this service from me. And then the contract is what kind of contract? Is it a month to month contract, monthly basis or yearly contract? So, what mode of contract is another variable important. Paperless billing is there or not is another variable. The payment method, whether he is paying through electronic check or whether he is paying through mail check or bank transfer or credit card, these are various kind of payment methods that they are using. And then there is monthly charges, total charges and churn. So, ultimately the prediction variable is churn, whether somebody is churning or not. So, first before I jump into predicting whether somebody churns or not, it is a very good practice to understand this data. See, it is not important or it is not only important to predict who is going to churn, but further more important for a marketing manager is how to stop churn. It is important to know that how I can do a simple thing which can stop churning, and that is why it is important to know that what are the predictors of churn, which are the variables which will lead to churning or not. So, for example, if I can see that whether there is a probability. So, what I am doing is I am doing a pivot analysis. So, I am selecting any cell here, going to insert pivot table, I am clicking on this pivot table and it selects the range and pressing OK. So, now I have the pivot table, and here in the right side I am dragging, let us say churn as my values or churn as my columns and let us say gender as my rows, and then count of churn as my values also. So, if you can see carefully that out of males, 3555 males in this data set, I will just make it bigger. Out of 3555 males, 930 are yes, 2625 are no, and here 939 yes and 2549 is no. So, I do not think there is much difference in terms of male and female and churning and not churning. So, I do not think gender is one of the major predictor of churning. So, this kind of basic initial level analysis you can do. Another is senior citizen. So, if I can check, okay, so senior citizen, you will be amused to see that if you are a senior citizen, your chances of churning is very high, almost 50%. If you are a not senior citizen, then your chances of churning is very low, almost like less than 25%. So, this is something which is interesting and counterintuitive. So, we had an idea that the senior people will be more sticky towards the service provider, and younger persons who might have more connectivity, who might have more information available with them, they are more tech savvy, they will have a tendency of switching. But here we are not seeing that, we are seeing the opposite thing. We are seeing that senior people, out of 1142 senior people, 1100 senior people, 476 is willing to switch. So, that is almost 40% is willing to switch. On the other hand, 5901 out of 6,000 people, around 1400 people are actually willing to switch, which is less than 25%. So, this is counterintuitive. Okay. Similarly, let us say partner. So, partner, I think that people who has partner, who does not have partner are less switch prone, who has partner are more switch prone. There has to be some reason of that. Probably it is so you have to actually discuss with yourself that why, as a marketing manager you have to discuss that why having a partner or not having a partner will actually impact your decision, because these might be more sticky, because your partner and you might be using the same telecom company. There can be some offers for your within network calls, within network message services and etc. Sometimes you also share the same data service with the company. So, the chances of switching if you have a partner is generally comes down. On the other hand, switching switching a telecom company when there is no partner probably will be, that is why much higher. What about dependence? See, it is the same thing, the partner and dependence goes hand in hand. So, if you have dependence, there are lots of guys who are, so if you have lots of kids, then you might be using the same one common internet service, one common data service, backup services and etc. Sometimes streaming services also, TV streaming and so on. So, then your chances of switching comes down, but if you are a single person, then your chances of switching will go up. Now, if I talk about tenure, so tenure has been taken here as, so tenure I cannot see it like this because it is a continuous data, but I can break it the tenure between, let us say if I just put it here and group tenure, let us say I am grouping tenure, right click, group tenure by let us say 0 to 72, I am grouping it by 20. So, you see when the tenure is 0 to 19, the chances is high switching, and slowly as the tenure increases, the chances of this thing comes down, chances of switching comes down. So, 320 by 1000 is 1/3 and 200 by it is 1/5 and 99 by this thing is how much, 1/13th. So, this is how slowly the chances of switching, chances of churning will come down when the tenure goes up. Then if I just say that monthly total charges, how much you charge, and if I then group this one, so it is saying that I cannot group this one, I am not sure why, because it is continuous data I think, but even then if I just check this thing, you will see that as we go up the charges, we have to see that how the charges and this thing are related to each other. We have to run a correlation analysis here instead of this kind of grouping, and we have to see that whether that works here as well or not. So, yeah, so we cannot do that here. So, this will not work, but let us say paperless billing or payment method. So, payment method wide also I can say that electronic check guys, those who are electronic giving data in electronic check, that means they are more I would say tech savvy than who mail check or who are doing bank transfer or credit card. So, these guys are more concerned towards switching and these guys are less switching prone. So, this kind of data we are getting here. Now, what I have done, so the description of the data is given here, you can check the senior citizen 1 is equal to yes, 0 is equal to no. So, that description is there. So, I do not save this data. What I did is I have changed this particular data to this churn data and I will try to predict churn. So, the code has been taken from rbloggers.com, it has been and the link has been shared here. So, we have changed the code depending on our necessary things whatever we are trying to do, but it has been I would say inspired by this particular link. So, you might get some amount of similarity there. So, what is the first thing that I am to do is to check that if tidyverse is there. If tidyverse is there, I will install the package tidyverse. So, I will just run this line. It checks whether tidyverse is there or not. If it is not there, it will install this particular library. So, it might take 1 minute. So, I will wait for 1 minute or so to let this particular thing get installed. So, tidyverse will be required to do certain analysis here. So, let us install it. So, while installing you see that the next step is I am calling this library here and then I will be reading the data. So, I have to set working directory to source file locations. So, and then I have to read this data. Some of the steps after this I will be doing quickly because I am just explaining it right now. So, this is quite quickly installing all these libraries, and once the libraries are installed, we will be calling this particular library. It is these are dependencies basically. Dependencies means some of the functions of this particular libraries will be used while doing this while using tidyverse. So, it is installing, still installing, it is almost done and now it will be done I think. Yes, so it is done, very good. So, there is a warning message, but there is no package called tidyverse, that is fine. So, I will call this library now tidyverse and it will be, once it is called, we will read the data. So, yes, so this is done and there are some issues, but there is no errors, and once that is done, I will set session directory to source file location and read the data. So, the data has been read. And then if I check the structure of the data shows like this, that these are all character variables. So, if these are all character variables that I am getting, the phone service, the multiple lines, the internet service, online security, online backup, I have to convert them to factor. So, the first thing is I convert the senior citizen to factor, and then I also use a janitor library, the library called janitor. So, this will not take much time, this is a small library that will be used. Yes, and that has been called, and then what I will do is I will just check the properties, and it is saying that in my data there is 5174 no churns and 1869 churns, which is 26% of people are churning, they are leaving this particular service provider, and 73% people are not leaving the service provider. Now, using this tidyverse library, I will be using this, that whenever there is a total charges, I will be, so if it is not other than total charges, everything I will convert to factor variable in this DB churn data set. And then what I will do is I will check that how many missing values are there. Based on that, I will reduce the number of variables. So, I am just checking the missing values is NA total charges. It is saying that in total charges how many missing values are there, and I am filtering it based on that. So, whenever there is no missing value, take that data. Whenever there is missing value, do not take that data. So, that kind of filtering I am doing. So, you will check this thing. 7043 was the previous case, it has come down to 7031. So, 7043 to 7031 is 11, and so 11 missing data has been dropped now. Then what? Then I will just draw the histogram of monthly charges. You see the histogram of monthly charges looks like this. So, which is not fairly distributed, which is not, and this one is further skewed, and tenure is also not equally distributed, it is also skewed. So, if that is the case, then I have to, and their distributions are different in shape also. So, not everybody has the same shape. So, if that is the case, I have to go and normalize it. So, the normalization function is, the output is basically x minus minimum of x divided by maximum of x minus minimum of x. So, we have done this normalization before. Normalized x, normalized x is equal to x minus minimum of x divided by maximum of x minus minimum of x. So, that is something, that is conversion I am doing such that the maximum values takes the value of 1 and the minimum value takes the values of 0, and in between values take in between values between 1 and 0. So, something like that we are trying to do here as well. So, we will be using this normalized function. So, I have just called the function right now, I have not used the function, I am just stored the function here in my environment. And then what I am doing, I am using another data set called dbchurn2, because original data set I am not handling that. All the conversion and etc. will do it in dbchurn2. So, I am creating another data set dbchurn2, and here I am normalizing total charges, I am normalizing monthly charges, the continuous variables. Other than the continuous variables, all other things we have categorized. So, monthly charges we are normalizing, and I am also normalizing tenure. So, these are some of the things that we have normalized now. So, if I have normalized this guys now, then the next step is basically, also you will see that there are in my data set dbchurn2, there are lots of factor data where there is no internet service. Now, no internet service means no only, no, there is no point on having another. So, what I am doing is for 1 to 5 and 7 to 16. What is 1 to 5? In dbchurn2 db underscore churn 2, if I just want to know the column names, so I will just write names of dbchurn2. I am getting 1 to 5, that means custom ID, gender, citizen, partner and dependents, these are categorical variable, and 7 to 16 means this to this, these are also categorical variables. In these categorical variables, the moment no internet service is there, you change it to no. If it is no phone service, change it to no, and then change them to factor. So, this is the changes that I am trying to do here. So, all the no internet service, no phone service, convert it to no, and then correspondingly you change all the categorical variables to factor variable. So, that is something that I have done here. Now, my job is to predict. So, that is why I will be creating a training and testing data, but by chance if you remember, by chance if your job was to explain, you would have done only whole data only, no training data, no testing data. So, I will be requiring a library called caret, I am calling it, it is getting installed, some variable, it will take 1 minute again. Yes, so caret is getting installed, and then I set seed 7. Set seed 7 is so that it becomes reproducible research. Whatever result I am getting in my computer, if I again run in my same computer again once more, the same results will come. so that this randomness, randomly we creating training data, testing data, the randomness is fixed at a system level. So, then training ID is dB $churn, p is equal to 0.7, means with a 0.7 probability you put it into the training data, list is equal to false and times is equal to 1. So, I am creating training ID using this training ID. Training ID is basically nothing but the numbers which will be ultimately be chosen. So, 3, 5, 6, 8, 9, some of the numbers in between has been dropped, and using these numbers I am creating training data and testing data. So, the numbers are going to training data and other numbers which are not here are going to testing data. So, my training data has 4924 and testing data has 2108 observations. Now, I will create my model on the training data and I will predict it on the testing data. Now, I here have chosen 3 models. One is decision tree, random forest and logistic regression, and testing I have done for all these 3 models. So, first is decision tree. So, for that I require library rpart and rpart plot, rpart and rpart.plot. So, these are the 2 library that has been downloaded. Now, I will run this data set. So, tree churn. So, you in a data, I am not going into what exactly is random forest or what exactly is decision tree. I am not going into that. That should have been covered in a different course, but this is actually creating a tree where based on various kinds of rules, you ultimately from the top node you come to certain node, and in that node based on the probability or based on the values that you have got, you find out the average of this particular node, that is a prediction. Whenever somebody comes in that node, that particular value is assigned to him. So, that is called decision tree. So, I will not go into the details of decision tree, I will just run it and it is giving me a result like this. So, it is telling me that if contract 1 year or 2 year is no, if one contract is 1 year or 2 year, then that is, if that is yes, so then you come here and otherwise you go there, and then you again check whether internet service is USL or no. If USL or no is yes, then you come here. If it is something else, you come here, and then if your tenure is greater than 0.2, I think, then you come here, otherwise go there. So, ultimate nodes are these 4 nodes, this one, this one, this one and this one, and here yes prediction is 0.7, here it is 0.41, here it is 0.29 and here is 0.6. So, the moment you are here, your probability of churning is very low. So, if you are have a contract of 1 year and 2 year, your chances of churning is very low. So, the first job the company should do is creating a contract. By chance if he is not getting a contract, then if he is using a data service USL, internet service USL or no, then his chances of switching is low, but by chance if he is using USL service or he is not. So, basically what is the other one other than USL and no, what is the other one in internet service, that is something that we have to also check. So, if I just check db_churn to $internet service, there is basically fiber optic, DSL, USL and no, right. So, just check the levels DSL, fiber optic and no. So, by chance if you are using fiber optic, that should have been here written. So, by chance if you are using fiber optic, then your chances of reneging is very low, otherwise your chances of switching is high. So, here it is 0.29. So, those who are not having a contract, but still using a fiber optic will have only 29% chances of switching. And then those who are not using fiber optic, but has a tenure greater than 0.2, they will have 70% chances of switching, and if it is less, then they have 0.41 chances of switching. I cannot see it properly. You can actually instead of plot, you can write down the tree, and this will be giving you exact. So, 0.204, that is the limit. So, you will get the exact rules here. Okay. Now, this is creating the tool only, that is all, we are not predicting yet. The next is random forest. I will be using random forest. So, random forest, I have asked for this particular package to get downloaded, and then I am using certain controls, and with those controls I am running this training, where I am saying that I need 75 trees, tune length will be 5, metric will be ROC to train the model. So, it is training the model, and the model specifications will be stored in model.rf. So, that is something that will happen for some time. I will just wait, and it might not take much time because the data is not very big, and it is done, and we have the model details. So, it has been given that the sensitivity when the MTRI is 2, 7, 12, 17, 23, how much is the sensitivity, ROC values, means that those things are given. And then our old school logistic regression. So, I am breaking the data set between, I am changing the churn. Do you remember the churn till now was yes, no. I am making it 1, 0, so that I can use it in my logistic regression formula 1, 0, and then I am using GLM, and then I am also using a step within a GLM. That means, it will take all the variables in the first go, and step function actually does the forward actually backward movement. So, it will drop one variable at a time to make sure that the AIC value is maximized, or log likelihood value is maximized. So, something like that. So, I will run, the AIC value should be minimized. So, okay, I got it, and the summary is something that I have got here. So, some of the variables, actually most of the variables are significant, and some a few are not significant. So, I could have probably dropped payment method from the model to do it. Now, once this is done, once all the 3 models are done, I have to do the testing. So, to do the testing, I have to run this ROAC library and then predict one by one. So, I will run this ROAC library, and for each of these 3 things, predict tree, predict RF, and predict logistic, I am predicting using the corresponding models. And once the prediction is done, I am plotting the ROC curves. Here, if you just see the ROC curves, you will find out that what this mean. So, the first one I have taken blue, then red, then green. So, if I just populate it, you will see that the blue line comes at the below, then the green line, then red line, and then green line. More or less red and green are same. Red and green are same means basically random forest and logistic function is same. Blue is the worst. Obviously, random forest is the ensemble model. It actually collects multiple trees data and then does the prediction. So, random forest will very high probability will actually be better than tree, but still I can show you very simplistically that logistic regression performs equally well, and in many practical situations that we use in our marketing, and that is why I focused on econometrics more rather than machine learning, that the logistic regression or linear regression, basic regression techniques has higher explanation power and higher prediction power also than certain machine learning techniques. So, here also we can say that our thing is good enough. You could have drawn a confusion matrix also to check the case that how it is good, how it is bad. So, to do that, what I will do is, you see that pred underscore logistic, this is a basically a factor which is which are basically probabilities. Now, if I just check that how much will I take, I can take anything between probably 0.3, 0.4 as my cutoff. If you remember, in the earlier one there was how much, when we started the analysis, when we started, we had we had around 0.26 as the that many yes, and 0.73 is no. So, maximum were no, a few were yes. So, if I can just write that probability of logistic is, or logistic 1 is, if else Pred dot logistic greater than 0.2653 2654 or 2257, then it is 1, otherwise 0. Okay. And now, if I just use this to create a cross tab. So, I write table Pred underscore logistic 1, table Pred underscore logistic 1, comma, and what is my another y variable that I am using. So, $test churn anyway, and then run. You will see that I am giving almost 447 times correct out of. So, this is my predicted value, this is my actual value. So, out of actually 113 and 447. So, 447 plus 113, 447 plus 113, which is 560. 447 divided by 560. This many times I am saying true positive. Out of all the positives, I am saying that out of all the actual chance, I am able to predict 79% of them using logistic regression alone. So, this is something that you have to check to see that whether you can do something or not. I can also use 0.5 as my prediction. So, in that case I have to check comma 0, and in this case it is much lesser, in this case it is much better. So, 314 divided by 560. So, I should have taken the cutoff much lower, and I have taken that, and this is giving my optimal result. So, optimal cutoff, you have to check the ROC curve, but optimal cutoff is oftentimes what was there in the training data, how much percentage you have to divide this probability in that percentage also. So, that is how we can predict. The explanation part is still not done yet. We will see in the rest of the part of this particular week how I can explain the churning behavior or customer lifetime value and etc. Using marketing data. So, thank you for being with me. We will continue on this kind of topic in the next video.